Midnight hook. Screen record. Terminal showing sudden exposure of secret API keys from a compromised Litellm package. Quick zoom to a GitHub security advisory blinking critical. Here's how 112,000 AI devs lost control of their projects overnight because of one compromised Python package, Litellm. Let's see exactly what happened, and by the end, you'll know how to check, clean, and lock down your own AI environment. 030, why this matters. B-roll, news headlines. PyPI Litellm hack exposes AI devs. Devs tweeting API key leaks. B-roll of AI-powered dashboards glitch. If you use Litellm, or really any package from PyPI, this isn't just some distant cybersecurity news. The Litellm attack in March 2026 actually sent API keys and sensitive variables straight to hackers. They didn't just target big companies. Solo devs, students, even hobbyists got burned. Why keep watching? Because I'll show step by step
How to find out if you're affected, how to secure your code, and 3 hard-won pro tips for next-gen security. 130 prerequisites. Screen recording. Checklist graph. 1. Python dev. 2. Uses Litellm 2025 or later. 3. Access to project files. Here's what you'll need. If you installed Litellm from PyPI in 2025 or 2026. If you use it with OpenAI, Claude, Gemini, or similar LLMs, and you can access your source code and virtual environments. That's it. No enterprise setup required. In fact, the biggest risk is that it's way too easy to get infected. Let's get right into it. 2 o'clock step 1. How the PyPI compromise happened. Screen recording. Timeline animation. Scrolling through PyPI Litellm release logs. Highlight the compromised 1.27.3 version. Let's start with what actually went down. Hackers gained access to the maintainer account for Litellm on PyPI. They pushed a fake update, version 1.27.3. The package itself looked normal, but hidden in the install script, there was a payload. Anyone installing or updating Litellm during a 2-day window pulled in that malware. Here's the dangerous part. The payload scraped your environment variables, the exact place most AI developers store their OpenAI and Anthropic API keys. Then it sent them, in plain text, to a remote server controlled by the attacker. B-roll. Code diff showing added malicious code. Zoom to OS at environment and request.post. This is what a modern supply chain attack looks like in 2026, and why you can't just trust pip install anymore. 330 step 2. Finding if you're affected. Screen recording. Developer running pip list, outdate, then checking pip show Litellm and opening package files. First, you need to check for the bad versions. Open your terminal. Run pip show Litellm. Note the version. If it says 1.27.3 or any version published on March 25th to 26, 2026, you're likely compromised. But don't stop there. Even if you've already upgraded, traces can remain. Check your Git history. Search for Litellm equals 1.27.3 or any regression to that bit. Open your site packages directory and scan for any unknown scripts or post-install hooks. B-roll. VS Code searching for Litellm and requirements.txt, then opening history tab. If you find a bad version, uninstall it immediately. Pip uninstall Litellm. Manually delete leftover files in your virtual environment to be thorough. 5 o'clock step 3. Securing your keys and environments. Screen recording, rotating API keys in OpenAI and Anthropic dashboards. Litellm's attack was laser focused on API keys in your environment variables. So, step 1. Go to all LLM providers you use with Litellm. OpenAI, Anthropic, Google, Mistral, you name it. Rotate every API key, even if you're not sure it was leaked. Delete any unused API keys. Don't just regenerate, delete, and create new ones with minimal permissions. Step 2. If you push .env files or configuration scripts to a public repo, do a rigorous sweep. GitHub has free secret scanning in 2026. Use it. Click security, secret scanning alerts in your repo. Fix every flag. 630 step 4. Clean and patch your projects. Screen recording, upgrading packages with pip, enabling package signing, and reviewing dependency graphs in VS Code. You've cleaned the infection. Now make sure you're patched. Upgrade Litellm and every other dependency to the latest legit version. Pip install, upgrade, require hashes Litellm. Turn on package integrity checking. Pip 24 plus now verifies sign wheels by default. If you disabled this, re-enable it. Pip config set global.require_sign true. In your requirements.txt, add hashes. The new PyPI security dashboard will generate these for you. B-roll, quick demo of enabling 2-factor on PyPI account. Package maintainers, don't skip this. Scan your project with pip audit and the safety tool. These will pick up known compromised packages and highlight what you're missing. 8 o'clock pro tips, going beyond basic protection. B-roll, side by side of dev with YubiKey and VS Code auto-rotating secrets. Let's talk advanced. 1. Use a hardened secrets manager, not plain environment variables. In 2026, tools like Doppler or AWS Secrets Manager now integrate directly with Python and VS Code. 2. For any package dependency in your stack, enable dependency track.
GitHub, GitLab, and even Bitbucket now alert you to risky updates in real time. 3. Watch for social engineering, not just code. The Litellm hack started as a phishing attack on the maintainer. Use hardware security keys, like a YubiKey, for every important account. 9 o'clock results and next steps. Screen recording. Checklist. 1. Uninstalled compromised version. 2. Rotated all keys. 3. Cleaned and updated environment. 4. Added package, signing, and audits. Let's recap. If you followed every step in this video, you're not just safe from Little, you future-proof your AI projects for whatever comes next. Most devs don't bother with these details. Now you know how to spot supply chain attacks, catch compromised Python packages, lock down your keys, clean your code, and get real alerts before damage is done. If this helped, subscribe. Next, I'm breaking down the real-world story of how the Claude API got brute forced by AI, not humans. Don't miss it. END.